There was a question about how saponin, or measuring the saponin question on cardiac, so I'm just going to do a quick review of that. Let's take a look at the data here. We have pre-saponin and after saponin right here. If you place the cursors to measure the interbeat interval, let's choose two of the wide peaks here to get that interbeat interval. So this is about 1.66 seconds. So that tells us the interbeat interval there. And we can use that to be able to determine the instantaneous heart rate. So for example, if instead of 1.166 seconds, we'd measured half a second for one beat for the interbeat interval, then we can just multiply that by 60 seconds per minute to determine the number of beats per minute. So think about it this way. When you're measuring that interbeat interval, you're basically asking, what is it? How many beats can I fit into a full minute? And so that's kind of what we're after. So that's the instantaneous heart rate. So you can do that before and after saponin. So here's saponin over here, and you can do that measurement after saponin. So this is, let's scroll down a little bit so we get a bit of a cleaner measurement. Here will work. And so we'll look after this here. So now it's 1.188 seconds. So you can look at that interbeat interval and calculate that. Once you have those two numbers, you can go into and put in the instantaneous heart rate. So in that case, it might be like something like 30, 35, 40, 30, after you do a couple of different measurements at rest, and then also after you've added your cardiac glycoside here. So maybe it's probably going to be pretty similar. And so we'll just make it 45 or something like that. So this will give you the average, and what you need to do that is be able to calculate the percent change, and that's what you can use this formula for. Just whatever pre is before you added the saponin, post is after you added the saponin. So it's whatever your average is here, 34 minus 33 over 33 times 100, and that will give you your percent change. So that's your percent change for your force. I'm sorry, for your instantaneous your heartbeat, and that will be plotted here. So if it was a large percent change, then it would be very big, but this is actually quite small, and you can calculate you would type in your number here. So let's say if it's actually 20%, it'll pop up in that graph. Okay, so then for the force, what you're going to want to do is plug in the numbers for force there. Let's go back to that. And how do you get that? Just to sort of remind you, it's similar to what we saw before. But I'm going to place one cursor at the trough, the other one at the peak of the major or largest contraction that we have here. And then look at V2 minus V1, that's 0.379 here. And you can do it for a couple of these to get the numbers to fill in to your spreadsheet. So 0.379 might fit in here, 0.379. And then you can measure, maybe you get 0.4, 0.376, 0.39 again, or something like that. So that would be your numbers there. And then you can calculate what it is after the glycoside 2. And so it might be a little bit, wouldn't that be great if it was actually higher? I don't think it actually is, but you can determine that. And whatever those numbers are, as you measure it, that V2 minus V1, you can determine it. So now you've got before and after your exposure to glycoside, and you can use that to calculate your percent change. And then you can type that in here. So you can, so in this case, your percent change would be your post exposure to glycoside, so 0.429. And your pre would be 0.386 over your pre times 100, and then that will give you your percent change. So I hope that helps the sort of sorting out some of the questions that you guys have.